difficult not to have imposter syndrome, right? Following up with that. So I just want to say on behalf of Capgemini, so firstly, it's a real pleasure to welcome all of you. I won't spend too much time speaking about what Capgemini does, because I'll speak a little bit more about why we're excited to be as a technology company now part of a drug discovery world. And as a biochemist myself by training, it's an exciting moment. I remember in March, I was at the Royal Society of Medicine where I met Sanj and Del. I was really impressed by the caliber of the speakers and what they were talking about in the world of drug discovery. But I did also notice that Recursion was up on stage, Google DeepMind was up on stage. It really is a moment to have a discussion around technology. And that's a little bit what I want to talk about. So LRIG is the beating heart of drug discovery in the UK. It's an extraordinary scientific organization. It's where science meets technology increasingly and engineering, where new modalities take shape. It's where the scientists in this room and the many other scientists that we'll see across the conference, they go after the hardest problems that we face as a human race. So it's really genuinely a privilege for us to share this space with you. There's a few of my colleagues around. We have some colleagues from our quantum lab. We, as Del mentioned, we have some colleagues from our global life science team, as well as some colleagues from our specialist Cambridge Consultings unit. And I would really encourage everyone to engage with them and learn a little bit more about what we do, because as what Del was mentioning is it's about not just building the technology infrastructure to allow scientists to do science, but also when the moment's right to take on some of those scientific endeavors. So we've had the privilege of doing this with large pharmas for a couple of decades, and we've seen how technology has evolved. It did start as kind of core IT consulting, build me a data center, build me cloud infrastructure, do some data engineering for me. But increasingly in the age of AI that we've experienced this year, that conversation is really, really different. But I want to talk for 1 second on, for the people in this room, we have some unique data problems. We end up in a lot of pressure being like, well, why is AI not revolutionizing absolutely everything? Well, it turns out like biological data is quite tricky to deal with. And in a recent discussion with MIT, they framed it in what they called the four biomedical questions or biomedical problems. The first one is, we struggle to build reliable data sets when we try to observe across different time points. And this can be driven by either the pace of biological progression of a disease, or simply our inability to look at something over time. The cells, sometimes we destroy them when we look at them. And so this challenge, like if you think of a car, you've got the same car. Each time you bring it in for a service, they're looking at the same car. We don't have that luxury in biology. That's the first challenge. The second is the complexity of associating data between different data modalities. So very frequently for us to do the discovery that we need to do, we need to look at sequencing data, but we also need to look at imaging data. And the same problem exists. It's quite difficult to have the same thing and get the same different modality data associated with it. Technology is increasingly able to associate and fix that problem. The third one is, unfortunately, solving disease doesn't always require just one simple intervention. And our requirement to sometimes have multiple interventions add orders of magnitude of complexity into the data problem associated with this. The final biomedical problem or question, and they all center around what they call transport or translation problems in the world of computational sciences, is that diseases don't happen on their own. And in many cases, there's other confounding factors, natural biological processes, such as aging. And this may interfere with what we're trying to study. And when you add all of this together, it creates a really big problem, right? But the good news is that over the last 50 years, there's been advances in both the biological world and how we understand biology and how we continue to build our understanding of biology, and the computational world. We've had new forms of memory, we've had cloud computing, and in parallel, we've had the steady march of artificial intelligence, which has gone through a couple of AI winters, and there's a lot of murmurs in the room at the moment around, are we going into another one? I personally don't believe we are. But it's the moment where the two worlds converge. So sequencing technology, imaging technology, transcriptomics, converging with the foundational models we have today and the other computation, whether they be probabilistic, deterministic. When they converge, and we talk a lot about converging technology amongst our teams, that's when things get exciting. And I believe it's a pivotal moment for all of us, and that's why we've decided to show up here. And we want to show up here as very humble technologists, some of us with scientific backgrounds, but this is your core world of drug discovery. And we really want to work with you to figure out how to apply technology, right? There's been a huge focus on like using AI and technology to just reduce cost, right? Efficiency, efficiency, efficiency. I will talk to you about efficiency of computation. I'll give you one number, and then I'm going to talk to you about why I think it's not just an efficiency play. We've all heard of NVIDIA. Everyone gets super excited about their market capitalization and their stock price and all of this. But I want to tell you some numbers about why NVIDIA really is in the news. One of the reasons people are so excited about NVIDIA, and it's such a valuable company, is the efficiency of their computational power. In the last 8 years alone, their GPUs performance has increased by 225 times. But as I mentioned, efficiency is not just doing more. That's not what we care about, right? If you take a $1 billion data center, let's build a theoretical $1 billion data center, and you ask some tough AI questions to it, that data center, right, in the last 8 years, has increased in capacity for answering questions 27,500 times. Then the sustainability question comes in. It's like, okay, well now that must be using a huge amount of energy, but that same data center that has a 27,500 greater capacity for answering tough computational questions is doing it with 43% less energy. So a per unit, it's like a per unit efficiency measure, it's 50,000 times more efficient than what we could do 8 years ago. And it's that unlock that has really delivered the OpenAIs, the Googles, the Metas of the world, the tooling that allowed them to do these amazing things that we experience with ChatGPT. And these are foundational technologies. Now, this is a technology that will permeate everything in our lives, and we need to start figuring out what that means for us. So this convergence in biology, right, is exciting for us. It allows us to do amazing things. We can augment DMTA cycles. We can really start to orchestrate scientific processes. But I want to bring it to head in a silly example. So if we agree that computation technology is excellent and we're starting to do amazing things, there's an ingredient called squalane. It's used in vaccine manufacturing and it's used in skincare. And if we were to get the world's supply of squalane from sharks, which is where it's naturally sourced, we'd have to kill 2 million sharks every single year. But our ability to harness both biological sciences and the computational sciences, the understanding of microbes, means we can use a 1 square kilometer sugarcane farm, and we can take microbes, and we can produce the world's squalane supply. And it's a silly example, but it's what we're doing in genomic medicine. And the example I wanted to go back to, which was around efficiency, is we were at Biotech a week ago, and they were talking about Formula One teams. Like, they also went through digital transformation, and their team size has actually expanded. Because what they did when they got new digital tools is they went after harder problems. And they now build the most advanced vehicles in the world. And they use more and more in silico modeling and simulation, and they have larger teams, but they build the most advanced vehicles in the world. And I really believe that's what we as a drug discovery community should be doing. We should be building the most advanced therapies in the world with all these new technologies that are coming through to us. And you know what, it's not only the example of increasing capability of technology that is allowing us to go after these problems, it's also the exceptional work that the teams are doing, and that's what we also here to discover over the next 2 days, is to learn a little bit more beyond. We spend our lives talking technology. The next 2 days, we're going to spend our lives speaking predominantly science to learn about the amazing scientific endeavors that all of you are pursuing and all of the incredible attendees. So I just want to say that it's a personal welcome from Capgemini, and a thank you to Del and to Sanj, and to echo the thank yous of Del for all the incredible team members that make this happen. This is an extraordinary event already, and we look forward to seeing more. So thank you, and enjoy the dinner.